Yeah. There it is. All right, so let's get started. Let's do that problem I finished ended the class with. We never had an opportunity to finish that out. Remember we had this mountain, right? And I had said we had a person who measured the angle up to the mountain. What was that first angle I gave you all? 63, and then the one to the left of that was? Okay, so this one's 67. This one's 67.
That one was 63. Wait.
No, that
The
one's
first one was 63, and then when you got closer, it was 67.
Okay, so I'm going to put another one out here then, right? Okay, so out here, this one was 63. All right, 63 degrees. And then the distance from here to here, I said, was what? 200 feet. All right, and so what we wanted to know was the height of the mountain, right? So I wanted to know what this h was. And that's all I gave you, right? That's it. So we drew a triangle that looked like this. This was 200, right? And this angle here was 63 degrees. So what we're doing is we're picking up this triangle right here, right? Like that. That is that picture. And then from that, we could also determine the rest of the angles in here. We determine this angle right here by using the fact that from here to here was 67, right? So the rest of it would be 180. So if you take 180 and subtract 67, what do we have? 113, right? So this angle is 113. And then that forced this angle to be, what was it, 4 degrees? Yes. 4 degrees. Right, so that's where we were, right, in class. And what I said at the end of class was what I would like to do is this. I would like to be able to get, here's H. I'd like to be able to look at this triangle right here, that one. That's this picture. I know that this is 67 degrees. And my suggestion was that if we could get that side, we'd be done. Like we'd be able to get H. Because this is a right triangle, correct? But I need to know what that side is. That side corresponds to this side of this triangle, right? So if I can find that, then I find it, I put it here, and then I'll show you how I'll get H once I have that, right? So can we get that side? Yeah? I'll call it, I don't know, let's call it little a, all right? Little a. If that's little a, then what is this angle 63 degrees? Big A, right? And then what else do I have? This side here, 200, I could call that B, little b. And that means angle big B is the 4 degrees. Oh, thank you. Right? Yes? Okay, so I'm going to now try and solve for little a. I have big A, I have big B, and I have little b. I'm not even going to be using C at all in this, all right? So because I'm solving for little a, I'm going to use law of sines, little a on top of sine of a. I'm going to write down first what I'm going to do. And then I'm going to do little b over sine of big B. Hey. Come on in, watch your step there. Oh, you're good. So little a over sine of capital A is little b over sine of capital B. And let's go ahead and do that, plug things in. I'm going to erase this. So I have little a, I don't know. Sine of capital A was 63 degrees equals little b, which was 200, and then sine of capital B, which was 4 degrees. Then I solve for little a by multiplying both sides by sine of 63 degrees. And get my calculator out, and I may have just left my calculator. Oh, did I forget it? Oh, I have my Big Daddy one here. Okay. I'm going to make sure I'm in degree mode. Uh-oh. My calculator's dead. I just used it. There it is. Okay. So 200. Does anyone have any questions while I'm doing this? I'm in degree mode on my calculator. Did someone get that yet or no? 2,554? Is that what you said? I'm going to double check. A is 2,554, 0.62, 0.6. Let's just go with 0.6, right? All right, we good? That allowed me to get this side. This side corresponds to this side now, right? And now I have a right triangle. And because I have a right triangle, I can use SOHCAHTOA, I can use Pythagorean, everything that I used to be able to do, I can now do, right? So let's label this side 2554.6. So what I want to do now is solve for h, right? I have this angle is 67 degrees. I have the hypotenuse, right? So I'm going to use which trig function that connects these two sides together? Sine, right? I know that sine of 67 degrees must be this side h divided by the hypotenuse over here, 2554.6. You see, this equation only has one variable in it, h, and that's what I'm solving for. I can do that on my calculator, and I can multiply both sides by 2554.6. So I'm going to just write down 2554.6. I'm going to take that and multiply that times sine of 67, and that will be equal to h. So I just cleared the fractions out, right? I multiplied 2554.6 on this side, 2554.6 on that side, and this I'm going to do on my calculator now. Who has it? 2,351. I'm just put it right here. 2,351.5 feet. That's how tall the mountain is. So remember, the whole point of this is that we have this real world physical problem where we want to measure how tall something is, but we actually can't get to it. So what we do is we take one measurement back here, we grab an angle, right? We get whatever this angle was, 67 degrees. That we can do. And then what we do is just back up, measure that distance. So back up, I went 200 feet, right? And then I measured the angle again, got 63 degrees. That's all you need to be able to find the height of that mountain, right? You just need those three measurements. We used the law of sines to get that side, and then we used our SOHCAHTOA to get the h. Clear? Yeah? No questions? All right, let's do a new problem. You ready for a new problem? I'm not going to tell you what we're doing yet, although I'm kind of giving it away on the board or on the TV screen over there, but I want to present the problem to you first. Chapter 9, it's technically we're getting into 9.3 right now, but just hang tight. Let me put the problem up here first. All right, so I have this triangle. I'm going to draw it for you. Looks like this. And I'm going to call this A here. Let's let this 41 degrees be C. Sorry, this is not, let me draw it bigger for you. Terrible. Terrible, terrible triangle. C equals 41 degrees. This is A. This is B here. And then I'm going to give you that this is 29 and that this is 13. I want us to solve this triangle. Solve the triangle. That means find all angles and all sides, right? All angles and all sides. So let's write down, like we did last class, let's write down the things that we're looking for. So let's go little, well, what did I do last time? Capital A, capital B, capital C, little a, little b, little c. What do I have? Little b, what's little b? 13. Right, here's the angle capital B, the side across from it, that's little b. All right, what else do I have?
Big Z.
Big C is 41 degrees, good. What else?
Little A.
Little a, and that's 29, right, little a. Yes? Okay. Can we find capital A and capital B right now by looking at this?
No.
Why not? I mean, I only have one of the three angles, right? So, whenever we are given two of the angles, we can always get the third one, right? But if we're only given one angle, it's not easy to get these two, right? We're given these two sides, A and B, but we don't have C, right? So I want us to see that we're going to run into a problem here, all right? Everyone needs to see this. Let's try and solve for C right now, little c. If we did that, I need to do little c over what? Sine of 41, no problems yet, right? Equals, and now this has to be either little a over sine capital A or little b over sine capital B, right? So let's try little a. Do we have little a? 29, right? Do we have capital A? No. You see, I can't use this because I need to know what C is, but to know C, I need to know what capital A is, which I don't have, right? So this isn't going to work. Okay, so I could have done this, little c over sine 41. This was me working with the A's. How about working with the B's? Do we know little b? Yeah, 13. But do we know capital B? No. So again, we have two unknowns, right? C and B we don't know. So can't use that. Do y'all see that? So what do? Right? What's happening here is that the information we're given about the triangle is not enough information for us to use the law of sines. All right? The law of sines does not work for the information that's been given to us. So we have a second law called the law of cosines, and it's right up there on the board. And so what I want to do first is start over. We'll get back to this problem in a moment. I'm going to erase this. We're just, really what we want to say here is, we're stuck, right? We're stuck at this point. We don't know what to do. We need something new. So let me draw an arbitrary triangle again, just like I did last class. Say we have an arbitrary triangle, looks like this. I don't remember how I labeled things. It does not matter how you label them. Okay, that's an arbitrary triangle. That's an oblique triangle, right? It's not a right triangle, it's an oblique triangle. And we know that off that triangle you have the law of sines, but now we have this law of cosines. So let me write down the first equation there. It says law of cosines. Law of cosines. First equation says this. A squared must be equal to B squared plus C squared minus 2 times B times C times cosine of capital A. So what I want to do here is I want to highlight a few things for you with this first formula. In red, I'm going to highlight what we can solve for. In this equation, do y'all see that we can go and try and find what a is, right? Because I have a squared equals this. In order to figure out what little a is, what do I need to be given? Well, I need to know little b, right? I need to know little c. Do y'all see how little b and little c appear in there? And I also need what? Capital A, right? Capital A. So, in other words, I can find little a, right, if I have little b, little c, and capital A. In terms of our picture here, that means this. I can find this side, right? I can find that side if I know what? This side, and that angle. The angle between the other two sides, right? I need to know, in order to find little a, I need to know the angle across from it, big A, and I need to know the sides on both sides of that angle. And then I can use the formula, right? Okay. Now there are two other formulas. They say the exact same thing though. I'm going to put the second formula up here. I'm going to draw a new triangle just so you can see that it says exactly the same thing, just changes your variables up a little bit. So if I do the same picture, A, B, C, little a, little c, little b, the second formula says b squared equals a squared plus c squared minus 2ac, 2a times c times cosine of capital B. I want everyone to understand that's the same formula as that one over there, just the letters are different. And the way to, I think, to see it best, again, is to draw the picture. Look, this is what we can solve for, right? We're going to solve for this. What do we need to know in order to solve for that? A and C, right? And then the angle capital B, which is this side, and that angle. Do you see it's across from B? We need that information. Same thing that we had here. When we want to solve for A, we need to know the angle across from it and the two sides. Yes? And then we could go and get the third formula. The third formula I'm not going to write down. I'm just going to draw the picture. This one we can solve for C, right? We can solve for little c, but we need to know the angle across, the angle across from it, right? And those two sides. That's what that formula says, the last one. Okay? So let's do the problem we were just stuck on and see about using this, one of these three formulas. So the one that we had was, try and draw it better this time. I'd said this was angle A, called this angle B. I told you this was 41 degrees. I said that's C, and I gave you 29 here and 13 here, right? So now when I'm looking at that, I already know law of sines doesn't work, right? We tried it, we couldn't get it. This is little c here, right? This is little c. This is little a. This is little, what is this? Little b, right? Little b. So do y'all see that we can find c because we have the angle across from it and we have the two sides, right? You see it? The angle across from C and the two sides, we have that information. So I'm going to use the formula that has C squared. And I'm going to write the formula down first. C squared equals A squared plus B squared minus 2A times B times cosine of capital C. So that means C squared equals, all right, A was 29, so 29 squared, plus B was 13 squared, minus 2 times 29 times 13 times cosine of 41 degrees. And we've got to make sure we do this correctly, order of operations, do it on your calculator. Just take your time, all right? You've got C squared equals, all right, so I'm going to just write all this out, all right? I'm going to do 29 squared first, 841, plus 13 squared is 169. And then we have minus, I'm just going to multiply those three numbers together. 2 times 29 times 13. That's 754. And then I'll just leave cosine 41 for now. Okay. Remember, you've got multiplication right here, right? So you've got to do these two together first before you start adding and subtracting things. So on my calculator, I'm going to do 754, and I'm going to multiply that times cosine of 41. Make sure I'm in degree mode. 569.1, something like that? About 569.1. Minus that, 841 here, plus 169 equals C squared. Questions up to that point? Now just add these up. Who else is getting 440.9? Yeah? 440.9. That's what C squared is, right? We need C, not C squared. So we're going to take the square root on both sides. So C will be equal to the square root. Now, when I do the square root, I'm supposed to do plus or minus, right? But remember, C is the length of the side of a triangle, so it's not going to be negative. So I'm going to throw away the negative answer. So the square root of 440.9, I'm only taking the positive answer here, so that raised to the 0.5. 20.99. Can we just say 21? Is that all right if we just round that to 21? All right, I've got C. I've got C. Now, let me list things out here. We have capital A, capital B, capital C. This was 41 degrees. We have little a, little b, little c. We know little a was 29. We know little b was 13. And we just solved for little c is 21. We still don't know capital A and capital B, right? So how should we go get those? We could use the law of sines now. The reason we can use the law of sines is because notice that we now have information, all the information we need for C, right? We didn't have that before. So now when we set up the law of sines, I'll be able to use, sine C over C, or I'll be able to do C over sine C, right? Like, I'll be able to set that ratio up. Before, I was missing this, right? And so I couldn't do it. So now I'm just going to go back and resort to the law of sines. And what do you want to go after first, capital A or capital B? It doesn't matter. You want to go capital A? Okay, so if I'm solving for capital A, what I'm going to do is put sine of capital A over little a, and then I'm going to be setting that equal to sine of capital C over little c. Because again, I know what that is, I know what that is, I know what that is, right? Like I have all that information in red. So sine of capital A over little a, which was 29, equals sine of capital C, so sine of 41 degrees, over little c, which is 21. And this is what we did yesterday, last class, right? So now we have sine capital A equals 29, multiply both sides by 29. Sine of 41 over 21. So sine of A is y'all can tell me. What do you get?
0.9.
0.9? 0.9. 91?
Well, it's
Nine.
905.
905? 91? Okay, now what? Inverse, right? But we have to remember that there are two angles that correspond to this y coordinate, aren't there? As we're saying again, on our unit circle, we have a y coordinate because it's sine, a y coordinate that's 0.91. That's like right here and right here. We're going to have to consider both possible angles. All right? So now in your calculator, take inverse sine on both sides. So the inverse sine of the inverse sine of A is A, and then the inverse sine of this on your calculator is, in degree mode, you should get a degree answer. So what's your answer? 65.51 degrees. All right, that's this angle right here. That's that first one, right? Or, what's the other angle? How do we get it again? We subtract that from 180. So what happens if you take that away from 180? You get 114.09? 49, yeah. 49 degrees. Do I need to look at both of these or not? Yeah, well, I do need to look at them, but can you throw one of them out or no? Yay or nay?
No.
Yes.
I'm hearing two different things. Okay. You said yes? Convince me.
Okay. So if you use 65.51, that means little b would have to be the rest of the angle, which would equal, what, about 90 degrees, given rough math, like an estimation. But b is also the smallest side, so it can't be the biggest angle.
Good. Okay. Let's see if y'all can, everyone wrap their heads around all that? So look, if we use 65.51, right? If we use 65.51, then we have 65.51 and 41. That's roughly 110 or 100 degrees or so, right? Which leaves us about 90 degrees. We could find it exactly, right? But then the sides, remember I said last class, the sides have to correspond. The biggest angle in this case would be what? If I did this, the biggest angle would be B, right? But B is the smallest side. And A is the biggest side, so it should be the biggest angle. It can't be this then, right? Do you see that? It can't be this. So I'm going to throw this one out, which forces it to be this one. Now you could probably see that in the picture, right? Do y'all see in the picture that A couldn't be 65 degrees? Right? But in the test, I'm not always going to give you the picture. I'm just going to give you information, and then you have to be able to deduce what's going on. So this case, very good, by the way. This is going to be our case right here. So we're going to let A be. Now I need precise answers. So we're going to let A be 114.49 degrees, and then now that allows me to solve for B, because I know that all those angles have to add up to be 180. Who has it? 24.51? Yep, degrees. And now we just take a step back and check, make sure everything looks right. The biggest angle is A, the biggest side is A, right? The smallest angle is B, the smallest side is B. The middle angle, the middle side. Everything matches up, all right? Y'all see how important this is, right? This is super critical when you get to this point right here, that you don't just go to your calculator and take that answer and be like, oh, that's the answer. You have to think through this. Questions? Shall we do another? I have a worksheet again for you. Take one, pass those back, please. I think there's enough there. Pass those back, please. Pass those back, please. Everybody have a copy? Let's take a look. I just did number 1. Let's take a look at number 3. So they give us A is 91 degrees. They give us 17. They give us 28. We're calling this side B, or this angle B, this angle C. 3, I think I'm doing number 3. So I know, I'm going to write things down. A, B, C, little a, little b, little c. I'm given capital A, right, 91 degrees. I have little b is 17 and little c is 28. Right, do y'all agree with that, the way I have this drawn? All right. So now that we know this thing about law of cosines, labeling my sides here, this is little a, this is little b, this is little c. Do y'all see why we have to do law of cosines? Everyone see it? This is what I'm solving for, right? I'm going to try and solve for little a. I can't get b and c because I only have one of the two angles, so I can't get those clean. I have this and I have these two sides. So I have the angle across from it and the two sides on each side of the angle. So this is perfect for law of cosines. Using the one over here, that is for what? A? Right? A squared? All right, I'm going to let you do that. I want you to see if you can do it on your calculator. We're using a squared equals b squared plus c squared minus 2 times b times c times cosine of capital A. I'm going to give you a minute. I'll be right back.